And welcome to this new Inventor 2019 course. So today I will be introducing you to the software and the interface. We'll have a look at what parametric modeling is, starting a part drawing, units and display, drawing planes and constraints. So I'll open up Inventor. So this should come up in your screen as soon as you open the software. If you click on part, it will open a part document, or if you click on assembly, an assembling document, or a drawing or a presentation. I highly recommend not to click here because it will open up a part, but Inventor is most likely to be set up to open up a part in inches by default. So instead, we're going to click in this icon in new, or use Control N. Make sure that you click on metric, and here you can see all the options that you've got. So for parts, I would always use, for anything you choose, I would use standard mill. So this is for a part drawing, this is for an assembly drawing, this is for normal drawings, and that's for presentations. So I'm going to go on standard mill part and click on create. Okay, so the first thing to mention is, what is parametric modeling? So unlike AutoCAD and other softwares that are not parametric, here you can, everything you draw or you generate goes here in your model tree, which is like a logbook that saves every step you take. You can basically edit anything that you've previously done. You can go back in time and change diameters or lengths and edit any feature that you would like. So otherwise, in non-parametric softwares, it's normally not so easy to change features that they have been previously created. Okay, so what's the difference of this? The difference is, in Inventor, you cannot sketch around the environment really easy. You're restricted to draw in planes or faces. You can create no planes, but you cannot sketch around the space like you would in AutoCAD, unless you start a 3D sketch, but it is not the same. So there are some advantages and disadvantages, but overall, for engineering, more likely you would be more comfortable using Inventor. Okay, so this is what we call the model tree. All of your tools are here for editing. Here you've got planes, axes, points, UCS. I'll be showing you all of that in the following videos. If we now go on the Tools tab, if by any chance you've got the wrong units, you can go on Document Settings and change your units here under Units. So we have mil, seconds, degrees and kilograms. That's correct. I'll close it. If we now go on the View tab, we can have a look at User Interface. So make sure that your model tree is on. This is your model tree. If you can't view it by any chance, you can turn it back on here. Or you can go on clean screen mode. I normally like to have my model tree here anyway. So, okay. So let's have a look at our planes. So if I left click on the YZ plane, I hold shift and left click on center point. I've just highlighted everything. So similarly to AutoCAD, you can either use your orbit here. So left click there and use free orbit. Or alternatively, you can always use shift and press the mouse wheel in order to move around. So as you can see here, that's my XY plane, that's my XZ plane, my YZ, my origin is right at the center, and then all of these are my different axes. So that's my X-axis, my Y-axis, and my Z-axis. So if you wish to start drawing, you can either click here on Start 2D Sketch, and now Inventor asks you what plane do you want to sketch on. So we're going to go on our XY plane. And now, as we can see here, the software is already swapping from 3D model to sketch, because we are sketching in 2D. So we have all of these tools that we had in AutoCAD that we already know how to use. We have a few new ones like project geometry that we will see in the following videos. And we have our constraints here. So I'll focus this video on what constraints are. We've already seen everything else. So we'll do an exercise on constraints, which is elemental for parametric modeling. So I'll just draw a random rectangle here, draw a circle maybe here, another one here. Now I will use the trim command, and I will trim half of the circle, this half, and this half. Okay, so what happens, we can just grab lines and move them around, pull them in any direction. So I'll quickly draw another line. Just so you know, in Inventor you can type in L, which is a shortcut for line. Inventor doesn't have commands though, like in AutoCAD. So once you press L, you don't have to press enter or anything, just L. So now if I draw a line at an angle. Okay, so these are our constraints. So here, for instance, we have our vertical and horizontal. So if I select vertical and select this actual line, then that means that our line will now become vertical. So our line is now restricted and it has to be vertical. If I now draw a line like this here, if I now say I want my line to be, I want to apply a coincident constraint, so I want this point at the end to be coincident with the midpoint, then that means that both points have to overlap. So as you can see now, both points are together. It doesn't matter where I move it, they are attached together. And if I now apply a perpendicular constraint, I can just select, I apply the coincident again, that's perpendicular. So I'll say I want this line to be perpendicular to this one. And it works. So this is how you normally make sketches in Inventor. Again, like in AutoCAD, you can, if you left click and hold, you can use your green selection tool or your red selection tool. So in AutoCAD it's slightly different, it's green and blue, here is green and red. So I'll select this, delete it. Okay, so let's have a look at this. Let's have a play with these constraints. So constraints are useful because you can fully define a sketch that will allow you to modify it after in certain directions that you wish. So first thing we probably want to do is, let's say I can move my circle in any direction without any restriction, and as you can see, it is simply because the centers are not aligned. So I can start by applying a vertical constraint between this point and this point, and now both points have to be vertically aligned. So now I can change the radius, but if I move this point or this point around, they are both vertically aligned as you can see. So the other thing that we've realized is this line is not aligned with this line, even though both lines are horizontal, as you can see, because we drew a rectangle. So when you draw a rectangle, Inventor applies horizontals and vertical constraints by default. So you can either apply a horizontal constraint between this point and this point, so now they are vertically aligned, or you can also use a collinear constraint. So let's say I'll go here on collinear, and I can say that I want this line to be collinear with this line. So now they are both, these are collinear and these are collinear. So next thing to do will be my circle is now not in the middle. So what we'll do, you can, for instance, if you want, you can apply a tangent constraint between this line and the circle, and it will disappear. You can also place a horizontal to this one. Probably before we proceed with the circles, it's probably best to define how far the width and length. So what we can do, we can say, okay, let's apply a dimension which will act as a constraint as well. So I'll click on this line and now close it, accept it. So now if I edit this dimension, which is a parameter, in this case D0, if I make it 100, it will automatically update and become 100. Now I can apply the same, I can give this a distance as well. So I can say I want that to be also 100. Let's make it a bit bigger. So let's make it 500. So that overall is 500. So now after defining that dimension, we can say, okay, the next thing that I want to do is I want the center of my circle to be horizontally aligned with this line, and the same with this one. So now both of our circles are aligned there. And now if we want to make sure that they stay at the center, I can enter another dimension and say, okay, I want the distance between this line and the circle, I want that to be, you can type in 250 or you can also type in, you can click on this dimension, divide it by 2, and press enter. So then if I make this 1000, sorry, not 100, 1000, then that becomes 500. If I make it 700, that becomes 350. So our sketch is always behaving the way we expect it to behave. So now we can change the diameter of our circle, so we can enter another dimension, make it maybe 50 mil, and then we can do the same with our bottom one. Or what we can do instead is, you can, for example, enter a dimension and now click on this one, so it becomes a function of it. So if now that is 100, the other one automatically becomes 100. Or instead you can delete it, and now you can apply a equal constraint. So you can say, I want this circle to be equal to this one. So whenever I make this one 150, the other one becomes 150. 100. So my recommendation is use constraints if possible. If you don't find a way to use constraints, use dimensions. So I would only use dimensions as a second choice. So now our sketch is fully defined. We can modify the diameter of our circles, the overall length, the overall height. However, when I click here, still freely moves. So we may want to place it somewhere else. So let's suppose that we want it to place this exactly in our center. So I can always apply a horizontal constraint from this midpoint and this midpoint. And now I can apply a vertical constraint between this center and this center. So now our sketch is exactly in the middle of our origin point, and I can just edit the dimensions, make it 200 if I want. Make it, if I change that and make it 500, then it becomes 500, 50. So I can freely edit everything. So all of these dimensions are parameters now. So that's D0. You can read it here, that's D1. That's D3. I can also type in a name. I can also say circle I think is the radius at the moment. Circle radius equals, has to be all together, forgot. Circle rad. Yes, it was a radius. So now when I go on my parameters, fx, now I can see all of those here. So D0 is that one, as we saw, D1 is that one, D2 is that one, and then circle radius is that one, which we enter the name by typing in the name circle rad space equals 100. So that's how you can also create your own parameters by saying add numeric, calling these, let's say, overall. The only difference is that didn't let me create it because I added a space, so I'll say length The only difference is that here are model parameters. Every single parameter will be listed in alphabetic order. So if you only want to create to modify certain parameters, it will take you a long time to find each separate parameter that you named, because they will all be mixed up. So if you set user parameters, they will all be tidy in your list. So I can set length 500. So here where it says equation, I can say 300, done. And now here I can say, I can type in length or equals length. Just type in the name of the parameter, or you can also click on this arrow, say list parameters, and find the parameters you created. Press enter, enter, and now that changes. So now I can go on my list of parameters and modify it from here. So as you can see, there are several ways of modifying an item. You can either edit the dimension directly or go into your parameters list. So if you're on the sketch, it's probably quicker to just double click and change in it. But if you are on on solid modeling, it's probably quicker to go on the parameters list rather than reopening the sketch. So I will be showing you a few more. So if I draw a circle, so now if I draw another circle, just a quick trick. If you use Control right click, you can see all of your constraints and you don't have to find them on the top, and they have a name as well. So I can also choose to make these two concentric, so I can say concentric, and now they are fully concentric. Now I can also say, for instance, shift right click, I can also say that I want my circle to be coincident. So I can say I want this center to be coincident with this center, and I will stay right on the middle. Another one could be, I can draw a line from here to here if I want to. I can say, oh, actually I want the line to be tangent to the circle, and it will become tangent and stay tangent. So we've seen coincident, collinear, concentric, fix. What fix does is it locks an item. So if I wanted this circle to stay here, I could just apply a fixed constraint, and now there would be no way to edit it or move it. So I don't recommend using fix. I would rather place the item, fully constrain it, and give it a dimension. So in the future, you can always edit the diameter or radius. So we have not seen parallel, so that's very easy to understand. If we draw a line, now we can make them both parallel. So the way this command works, all of these constraints, sorry, you may be wondering, oh, actually, if I make two lines parallel, what one will become parallel to what? Basically, the line that is more constrained, you'll be the one that stays the same, and the other line will the unconstrained line will adapt to the constrained one. So we've seen horizontal, vertical, tangent. Smooth is not normally used, but we'll maybe see it. Symmetric, and we'll see it in the following videos, and we've seen equal. So now I'll just quickly delete these few lines, finish my sketch. So now, as you can see, Inventor switches from sketch mode to 3D modeling. So now I can go on extrude my sketch, so I can say 200 or whatever distance. Or I can make these a parameter as well. And if I wish to edit it, I can always go on my parameters and modify it here. So I can say, okay, I want this here, I want it to be 500. And I want my length to be 1000. Or my radius to be 500. Say 300. So yeah, you can edit anything you do. You just have to make sure that you can find your model parameters or create your own ones and find where they are. It's a very effective tool. So I hope that the concept of parametric modeling is now clear. We'll be going into more depth in the following videos. So this will be it for today. So thank you very much for watching, and I'll see you in the next one.